Number 33. A box of mass m is on an inclined plane that makes an angle of theta with a horizontal. It is in contact with the spring of spring constant k. The box is released and it compresses the spring an amount delta x before rebounding. In terms of m, g, k, and theta, what's the value of delta x? All right, so initially when it's just in contact with the spring, the type of energy that it has is GPE. And that's GPE initial. After we release the box and it slides down the incline, compressing the spring, it's going to end up with a different height or a different gravitational potential energy or a final gravitational potential energy. It also is going to have elastic potential energy at its maximum when it fully compresses the spring. Substituting in the equations for GPE and EPE, we would have mgh initial equals mgh final plus 1/2 k delta x squared. All right, so what we want to do at this point is get delta x by itself. All right, so we'll have 1/2 k delta x squared equals mgh initial minus mgh final. All right. We can factor out a negative mg, and we're going to get mg times delta h. Delta h is going to equal delta x sine theta. Then we could cancel out the delta x, divide by delta x, and we can get rid of the squared. So we're left with 1/2 k delta x equals negative mg sine theta. We can multiply both sides by 2 and divide by k to get delta x by itself. And we get an answer of delta x equals 2/k times parentheses negative mg sine theta, which closely resembles this. The negative sign comes into play because the change in height would be final minus initial, so we're getting a negative minus a positive, and that's the reason why it's a negative sign.